Okay, so we'll start with power electronics lecture number 14. So yesterday we covered single phase semi converter with resistive load. So today we'll continue to discuss it and start with single phase semi converter with RL load. In RL load there are two configurations, symmetric and asymmetric. So in symmetric configuration, SCR is present in each different leg. Whereas in case of asymmetric, it's present in the same leg. Yesterday we have seen that, right? So also we will assume one more thing, that a load current is continuous. Now what do you mean by load current continuous? Let's say that this is my output load current, right? And it has a average DC value like this. So what do you mean by continuous over here is that the fluctuations in the load current is very minimum. Now let's say this load current is, let's say, 15 amperes. Now what do you mean by fluctuation? So this positive peak might be 15.1 ampere. This negative peak might be, which is going down, might be 15.9. So the variation from 15.1 to 14.9 is treated as continuous. And this happens when the value of L is very high. So for all the practical purposes, the continuous mode of operation is preferred. Is that fine? Yeah. Now over here, this is the circuit diagram of circuit configuration for single phase semiconductor with RL load. Please draw it in your books quickly. So over here, T1 and T2 are your SERs, which are control devices. You can control the on time of, when the SER turns on, and D1 and D2 are the power diodes. Now power diodes are controlled or uncontrolled? They are uncontrolled. You cannot control its on time, or neither you can control when it turns off. And the load current is continuous. You know what will happen when there is an inductor? During the positive half cycle, inductor will store the energy, and during the negative half cycle, it will release the stored energy. Right? But in this case, it will not release completely. I've given you the example before. Let's say you have water tank, 5,000-liter water tank, and requirement is like 500 liters of water. So if 500 liters of water, even if you remove it, how much is remaining? 4,500. So there's a lot of stored energy if the value of L is very high, because the voltage across the inductor is given by the formula L di by dt. If the value of L is larger, it will store more energy, as simple as that. And for continuous mode of operation, we assume that the load current is continuous and the value of inductor is large. So during the negative half cycle, it will not go to zero. Current will not go to zero. It will be slightly declining. That's it. Something like this. Okay, it's not going to zero. In discontinuous mode, it goes to zero at beta. But here it's not, does not go to zero. So which mode is preferred, continuous or discontinuous? In practical applications, continuous may the current never reaches zero. So during the operation, let's say if you want to operate a DC motor, do you want your DC motor to stop in between the operation? No. You want a continuous operation, right? So continuous mode is preferred in practical applications over discontinuous mode. Discontinuous mode में current becomes zero, or pi plus beta or 2 pi plus beta. Okay? Have you drawn? Draw it carefully. So what are the two conditions for SCR to turn on? First, it should be forward bias or forward blocking mode. Second, gate trigger should appear. So during the positive half cycle, T1 and D1 will be on. D1 तो ऐसे ही on हो जाएगा. Then D1 will turn on. The moment you apply positive half cycle, 0 degree, 0.5 degree में on हो जाएगा. Because for diode to turn on, what is required? Anode voltage greater than cathode voltage. We are assuming ideal diodes, ideal power diodes. मतलब वो जैसे on होगा, उसके across voltage will be 0, right? And when does the SCR turn on? Forward bias plus gate trigger. Have you drawn it? Okay. So today I will follow a different approach because I have to cover a wide variety. I won't be drawing the waveform. I have already drawn the waveform and I'll explain from there, part by part. Yeah. These are the waveforms. I'll keep the waveforms on one side and I'll start explaining now. So load current is continuous. This is the meaning of load current continuous. Load current continuous. Fine. So now, whenever there is a continuous case, now do not start with 0 to alpha. Start with alpha onwards. I'll explain why. So now explain the period between alpha and pi. Alpha and pi. What happens between alpha and pi? Alpha, after alpha, what happens? The T1, which is in forward blocking mode, due to due to positive half cycle, it turns on. So T1 will turn on. What about D1? Diode D1? It will turn on during positive half cycle at omega t equal to 0 only, right? Then what else? Does my SCR-T2 will turn on? No, it will only turn on during the negative half cycle and D2 also. So these two are off, these two are on. What will happen now? From alpha to pi. So what will happen is the current will start to flow. Let's call this A and B, C and D. The current will start flowing from over here. Let me call this I in source current. And the conduction will be A, T1, C, RL load, D, D1 and B. So current will start flow and input source current is equal to the output source current, right? What about the output voltage? Output voltage, the input source voltage is transferred to the output via T1 and D1. So V out and V in will be same. Okay, so that means the output will follow the input voltage. Right? At the same time, what is happening in the inductor? Inductor, when it is in the positive half cycle, it is storing the energy at the same time. So alpha to pi means what happens? T1 and D1 conducts. Output is equal to input. Load current is equal to input current, and it will follow the trend. So this is what will happen. This is my load current increasing. That means the inductor is storing the energy till pi. What is my output voltage in this period from alpha to pi? It will follow input, the red color one. And what about the input voltage? Input current. The input current will follow the load current because they are same from alpha to pi. Agree? So from alpha to pi, T1 and D1 conducts. Any problem over here? Any doubt? So in the meanwhile, you all can also start drawing the waveforms simultaneously. Acha, when T1 conducts, the voltage across the T1 will be 0. Here it is shown 0 from alpha to pi. Okay? Now, next, from pi to pi plus alpha, what happens? After pi, your negative half cycle starts. So the inductor will not store energy, it will release the energy. अगर उसने energy release किया, तो its current will start reducing. But बहुत बड़ा value है L का. So it has lot of stored energy. So अगर 5000 में से 500 किया तो 4500 बचा. So it will slightly decrease, but not these two. This is the meaning of continuous. Continuous मतलब ये I max. The maximum value of load current and minimum value of load current will have same peak. Upper peak and lower peak will be same. That is the meaning of continuous. Okay. So now current is reducing. But what happens to SCR T1? Will T1 continue to conduct? Yes. SCR will continue to conduct even if it is negative half cycle. Negative half cycle, right? Who is helping? Inductor. So inductor will keep the SCR1 conducting till pi plus alpha. Correct? Are yes or no? From pi to pi plus alpha, your SCR T1, which should turn off at pi, it is conducting from pi to pi plus alpha, inductor stored energy. Okay? Inductor stored energy is keeping it on. So during positive half cycle, the polarity across the inductor will be like this. Plus up, minus below. But during the negative half cycle, when it's releasing the energy, the polarity will become like this. Now it is aiding with the negative half supply, and then again it is keeping the T1 on. Now next what will happen? What happens to D1? what happens to D1? See, initially during the positive half cycle, T1 and I mean from till pi, T1 and D1 are on. जब भी T1 and D1 on है, it's as good as short circuit. T2 and D2 are off. अभी negative half cycle आया. So what does the negative half cycle did? This is positive, right? So this positive will go over here, and this will go over here. So ये positive हो गया anode terminal of D2, right? What about the cathode terminal of D2? ये negative will come over here. That means as soon as omega t reaches pi and input is negative, your D2 will become forward bias. Forward bias मतलब on हो गया. D1 off हो गया, D2 on हो गया. So what happens between pi to pi plus alpha? T1 is on and D2 is on. So this will be the picture. ये off है, T1 is off, D2 is on, T1 is on. अभी क्या होगा? What will happen? See this blue color part which I have shown, right? So this entire load current will flow via this short circuit. अभी short circuit हो गया ना, T1, D2. So whatever is the energy stored in the inductor, it will freewheel through T1 and D2 because it's a short circuit. So अगर short circuit आ गया output में, तो output will become, it is a short circuit appearing in parallel with the output. Output will become 0. So that is what is happening over here. Between pi to pi plus alpha, T1 and D2 are conducting. So they are freewheeling the energy stored in the inductor. But the output becomes 0 now. This blue color part. This diagrams you need not draw in the exam. ये तुम्हारी understanding के लिए बनाया यहाँ पे. It's not given in the books also. समझ में आया what happens? So during alpha to pi, it's a conducting phase. T1 and D1 is conducting. From pi to pi plus alpha, T1 and D2 are conducting. You understood how? नहीं समझा बेटा? Understood how? Yeah. Okay. Fine. Now, next what happens from pi plus alpha to 2 pi? Same story will repeat, but now T2 and D2 are eligible to conduct. And they will conduct because यहाँ पे pulse आ गया ना. This is actually IG2. IG1 है. IG1, IG2. Now you will tell me, I mean, you will say, in the negative half cycle, your SCR-T2 is eligible to conduct, but conduct नहीं कर रहा है, forward blocking mode में. After pi plus alpha, it starts conducting. बराबर? So T2 will start conducting, and D2 is already conducting because reverse, I mean, negative half cycle. D2 is already conducting, right? So this will be the picture. ऐसे होगा. Now the current input source current पहले इधर था, A से flow रहा था, now it will flow like this. So now how will be the conduction from B, T2, C, RL, D, D2 back to A. So the current direction of I out and I in have reversed, but they are same in magnitude. So I out will be minus of I in. What about output voltage? Input voltage reverse है, output voltage positive ही है. मतलब output is following negative of input. But even if the input is going negative, output positive ही है. In semi converter, output voltage and output load current is always positive. One quadrant converter है ना? Yesterday we talked about, right? So this is what will happen. So T2 and D2 are on, and this is the way current will flow, and output will be following the inverted of input. In terms of waveforms, this happens. See, input is going down, but output is positive, and it will follow the negative of input. What about the current? Current across the load is in the same direction, so it will charge the inductor, will store the energy. Same way. Understanding? This I am explaining from pi plus alpha to 2 pi. Now same thing. What will happen from 2 pi to alpha? 2 pi to 2 pi plus alpha. T2 will continue to conduct because of inductor stored energy, and now D1 will turn on. Why D1 क्यों turn on हो गया? Because देखो after 2 pi positive half cycle has started. So as soon as D1 turns on, T2 will turn on. And this T2 D1 is my freewheeling period. अगर वो on हो गए, तो this will be the scenario. ऐसे हो जाएगा देखो. Now T2 and D1 are on. So what will happen? The entire current will flow through this part. So it will freewheel the energy across the inductor. So now what will be the output voltage? Zero, because short circuit हो गया ना देखो. The short circuit coming in parallel with the load. So hence the output voltage is zero during the freewheeling period. ये देखो. Output voltage is zero from 2 pi to 2 pi plus alpha. And then again the cycle will repeat. But during this period, pi plus alpha to 2 pi, my input source current is negative. See, it's going from below. Current direction is negative. But the wave shape is same. That's why the waveform is like this. It will follow same but in the reverse direction. अच्छा बताओ करंट क्यों जीरो है फ्रॉम पाई टू पाई प्लस अल्फा करंट जीरो क्यों है यहाँ पे why the input source current is zero because वो कुछ ही नहीं करता है input source current को input source current is not responsible for the output now entire loop is between output and D2 and T1 that's it input आया ही नहीं picture में so hence the current input source current is zero during the free ये वाला current source current is zero same way over here also यहाँ पे इनपुट आ ही नहीं रहा है बिकॉज द करंट इज फ्लोइंग फ्रॉम आई आउट एंड दिस लूप सो दैट्स व्हाई करंट इज जीरो आई इन करंट इज जीरो आर यू फॉलोइंग राइट सो ड्रॉ दिस वेवफॉर्म्स क्विकली अच्छा मैंने एक्सप्लेन ही नहीं किया जीरो टू अल्फा में क्या होता है सिंस इट इज अ कंटिन्यूअस मोड यू टेल मी व्हाट विल हैपन एट जीरो टू अल्फा ये कंटिन्यूअस मोड ऑफ ऑपरेशन है ना 0 to alpha is again a freewheeling period. Output the previous cycle follow कर रहा है. So previously what should happen over here? Follow the trend. T1 D1 should be on. You follow the trend. When it is a continuous state, start from alpha. So 0 to alpha will be similar. If you go backwards. Are you following? So have you drawn the waveforms? One good thing about semi-converter is that the output wave shape in case of continuous current is same for R load, RL load and RLE load. Output same है ना जो and the expressions are same. Only in case of discontinuous it changes. So draw whatever you want to draw quickly. Waveforms are completed. Acha, tell me which are the freewheeling period in this section. Pi, 0 to alpha, pi to pi plus alpha, 2 pi to 2 pi plus alpha. These are freewheeling period. Freewheeling period में input source current is 0, output voltage is 0. What about a conduction period? Alpha to pi, pi plus alpha to 2 pi plus alpha to 3 pi. These are conducting period. Okay? Have you drawn? This is also called as single phase semi-converter, with bridge configuration. It's a bridge, na? Full wave bridge rectifier we say. In this case, it is a controlled rectifier. What is the other name for it? Half controlled. See, many people, in spite of knowing everything, do the mistake in exam, they read the question wrong. जैसे कंट्रोल रेक्टिफायर लिखा टूट पड़ते हैं जैसे फुल वेव रेक्टिफायर में ना टूट पड़ते हैं पढ़ो fully controlled or half controlled. You might write full converter. That's a fully controlled. It is a 2 SCR. It's a half controlled. Okay? You understood why it is full control and half control? यहाँ पे control only for one cycle है. Other cycle controllable ही नहीं. वहाँ पे all the cycles are controllable, positive and negative both. So that's why fully controlled. Remember again one thing, we can control when the SCR starts. We cannot control when the SCR stops working. So turning on of SCR is under our control, turning off of SCR is not under our control. What about the diode? Diode में कुछ भी control नहीं कर सकते. Neither we can control when does the diode turn on, nor it turns off. It's an uncontrolled device. Remember this thing. Drawn the waveforms? Yeah, can I proceed? हाँ ये voltage across the thyristor. See, your T1 will conduct. T1 is on from year to year, right? And T2 is on from year to year. So when T1 is off, when the thyristor T1 is off, the voltage across the thyristor T1 is equal to V. So it will follow V. When it is on, it will be 0. Completed? What about the expressions now? Write down the expressions again. V out average, it's same as I told you all. Output wave shape is not changing for continuous current case. It's same for R load, RL load and RLE load for semi converter. So V out average will be Vm upon pi 1 plus cos alpha. Write down the circuit turn off time. Tc is pi minus alpha upon omega. Write it down. Circuit turn off time is pi minus alpha upon omega. And what about V out RMS? Vm into pi minus alpha upon 2 pi plus sine 2 alpha upon 4 pi raised to half. But there is one question. Normally, जब भी freewheeling period होता है, so we connect a external freewheeling diode. इसमें बिना without connecting a freewheeling diode, still it is having a freewheeling effect. So what will happen if we externally connect a freewheeling diode? ऐसे. Do you see that freewheeling diode over here? इससे क्या फर्क होगा? What will happen? I'll explain now. Wait. हाँ देखो अभी इधर देखो. Concentrate on this is a very interesting thing. Now, you know you have studied, I mean, just now we have discussed that between pi to pi plus alpha, T1 and T2 are on. So, freewheel होने के लिए, you have part number 2, which we have discussed. But now, at the same time, if we have connected a freewheeling diode, वो भी on है. So, there are two parts, blue color, part 1 and part 2. So, which one will you prefer? Or which one the semi-converter will prefer? Part 1 or 2? Practically, what you should consider? 1 or 2? I'll tell you should consider part number 2 for two reasons. First of all, ये जो T1, T2, D1, D2 है, इसके पूरा semi converter dependent है. If something happens to these devices, wrong, faulty, you should always protect them. इसलिए externally लगाया है, you connect a separate freewheeling diode. Second reason is, we are assuming that these are ideal devices. But practically ऐसे होता नहीं है. The voltage across the SCR is 1 or 2 volt or even greater than that. When it is on, हम लोग zero assume करते हैं. And voltage across the diode, when it is on, how much it is 0.7. I'll know that. So, इस case में when you have part 2, you have two devices in series. So let's say voltage across the T1 is 2 volt and voltage across the diode is 0.7. So 2.7 voltage आके across the output. Right? What about part 1? SCR नहीं है, खाली diode है. So 0.7 volt ही है. So always it will prefer the least resistance part. Whenever diode is on, it will offer on resistance. Whenever SCR is on, it will offer on resistance. So यहाँ पे resistance ज़्यादा है, part 2. So part 1 will be preferred. Are you following? So externally freewheeling भी है इसमें, internal freewheeling भी है. Similarly, is the period between 2 pi to 2 pi plus alpha. Part 2 is between T2 and D1. They both are on. But if you connect a freewheeling diode, that freewheeling diode will be on. And the energy across the inductor will be released instantly. And the output voltage will become 0. It will not go negative. Okay? You have understood the meaning of this? Why? What is the advantage of connecting an external freewheeling diode? In reverse bias, I mean in opposite, anode and cathode is reverse over here. Fine? Are you following? नेक्स्ट ये you just draw the circuit diagram and keep it ready. ये asymmetric configuration है. Why it is asymmetric? As you can see, the SCRs in the same leg. T1 and T2 are in the same leg. So that's why it's a asymmetric configuration. The waveforms are exactly the same. पूरे के पूरे same है. What's the difference? Here we have assumed the ideal scenario. हम लोग ने क्या assume किया है? We have assumed the load current to be constant only. पहले क्या था? Fluctuations है ना थोड़े. Now we have assumed it to be constant. अगर load current constant है at an extremely high value of voltage, what will be the effect? See, load source current waveform are becoming like a rectangular shape. It was like a smooth, I mean, with a square wave with a ripple, close to square wave, but now it is a pure square wave. Okay, and this yeah, and the functioning will be slightly different, but the wave shape will be same. And also, here is the difference. In the earlier case, T1 was conducting till pi plus alpha, right? यहाँ पे वो तभी तक नहीं conduct करे. There's a difference. So let's see what's the difference. Okay. So always when there's a continuous current, you have drawn the diagram. Sorry, please draw the diagram first. I have highlighted D1 and D2 as a yellow color, highlighting that those are diodes. Diodes है D1 and D2, power diodes, which can handle higher value of current and voltage. This is asymmetric configuration. Single phase semiconductor with asymmetric configuration. Waveforms are exactly the same. But we have assumed a constant load current. It's constant throughout, not decreasing, not increasing. So let's consider an example. Let's say that you have a water tank which has a capacity of storing 5 lakh liters of water, and your requirement is 500. So 5 lakh में से if you remove 500, it will be overall constant only, right? ऐसे मतलब कुछ फर्क ही नहीं पड़ेगा. What is 500 in comparison to 5 lakh? So load current constant रहेगा. That's what is happening. Even if there is a freewheeling, it will freewheel at 500. But remaining 4,95,000 will remain as good as 5 lakh. This I am giving analogy. Completed? Okay, let's start. So always start from pi to alpha in case of continuous. So pi to alpha, what will happen? Same thing. Not so much difference. So in the positive half cycle, the current will flow from A, T1 and D2, D1 is on. Same story. So it will flow from A, T1, C, R, L load, D, D1 back to P. So I out will flow, inductor will store the energy now, and in the same time T2 and D2 are off. So your current will flow, I out will be equal to I in, V out will be equal to V in, the VT1 will be 0, right? So this is the scenario. From alpha to pi. This is alpha to pi, it will follow the input. The load current will be input current will be same as load current, and load current is a constant. So it will be constant from alpha to pi. Now what happens between alpha to pi plus alpha? यहाँ पे difference आता है. See, the position of SCRs are different now. Positions of SCRs are different, so it will matter. Now what will happen? See carefully. Now you go from pi to pi plus alpha. Pay attention. If you understand this, it's repetitive further. Now you are going from negative half cycle. Input negative हो रहा है, right? So negative हो रहा है. I have drawn the scenario. At omega t equal to pi, negative जाने वाला है, right? It's going into negative half cycle. उसके पहले नेगेटिव होने से पहले, इनपुट के नेगेटिव होने से पहले T1 and D1 are on. On मतलब शॉर्ट सर्किट है. T2 is off only. T2 पहले से ही ऑफ है, right? So this is the scenario. अभी क्या हो रहा है, ये वर्डिंग्स देखो. अभी नेगेटिव हाफ साइकिल में गए, So this negative will come over here. This positive will come over here. This positive. This positive will come over here. Right? Correct? And inductor stored energy is releasing now. So, abhi inductor stored energy is releasing its polarities like this. Right? So what it will do, what this will do. What this is doing. Now due to this arrangement, what is happening? T1 reverse bias हो रहा है. कैसे? ये negative इधर आ रहा है. And positive ऊपर आ रहा है. Right? So it will become reverse bias. So T1 बंद हो गया. Earlier case में T1 was on. But इधर बंद हो गया. What happened to D1? D1 at pi नेगेटिव ऑफ साइकिल में बंद होना चाहिए ना, पर वो ऑन ही है अभी. कैसे? Because of the arrangement. Because of this arrangement, this positive voltage is coming here, right? Yes or no? It will remain to it will remain in the forward bias condition. It will remain in the forward bias condition. It will remain on. And what about D2? D2 negative ऑफ साइकिल में तो ऑन ही है ना. So now D2 and D1 are on. ये देखो. This is what will happen. In the freewheeling period, D1 and D2 are on. T1 on नहीं है, T1 off हो गया at pi itself. It is commutated by line commutation. Reverse voltage आ गया ना इसके across. So it is off. So output again will be 0 over here. But now this is due to D1 and D2. Not due to T1 and D2. Now after that what happens? After that pi plus alpha comes. You get another trigger pulse. So now T2 will turn on, T2 will turn on. बाकी सब ऑफ हो जाएगा. And again, same story will follow. Here it is. The current will flow from below. B, D2, C, RL load, D, D2 and A. So polarity of the I out current and IN current will reverse. Right? What about the input voltage? I mean, input voltage is negative, but output voltage is positive. So it will follow the negative of input. Same thing will happen. Exactly the same. So now output voltage will follow negative of input. Alright? What about the current? The current is going negative now, so it will follow the input, I mean the load current, but it will be in reverse direction. Again, the current is 0, source current is 0 from pi to pi plus alpha. Why? Because यहाँ पे source disconnect ही हो गया ना. देखो, source का काम ही नहीं है. Source is like open circuit. So now entire current will flow over here through this loop. So again, this will act as a freewheeling mode. But this time D1 and D2 are working together. Are you following? Same waveforms. Now, what will happen? Did you understand till pi plus alpha to 2 pi? How D2 and D2 will be on and they will continue carry the current, load current. Now, what happens between 2 pi and 2 pi plus alpha? Abhi dekho, beyond 2 pi, input is going positive, so D1 on ही है. D1 will become forward bias. Why D2 is on? Because of the arrangement. Similarly, which we have discussed earlier. You know, when we discuss now from pi to pi plus alpha, same way D1 and D2 will be responsible for freewheeling action between 2 pi and 2 pi plus alpha. And the process will repeat itself. Earlier kya tha? Because of in the symmetric configuration, T1 and D2 were conducted in this period. In this period, what was conducting? T2 and D1 was conducting. But here, freewheeling is happening only because of diode, directly, because of the arrangement, because of way they are connected. Okay, fine. What's the difference from here to here? Earlier, T1 was conducting from alpha to pi plus alpha. Now it is conducting till here to here. T1 is on, यहाँ पे T2 is on. So what's the difference? The current which is carried by the transistor when it is on, average, it is more in case of earlier configuration. But transistors have to carry a longer current for a longer duration. That's why current rating for symmetric configuration for SCR should be higher. compared to this. अरे वोल्टेज जीरो है, करंट तो मैक्सिमम करंट तो ज्यादा है ना. When it is a short circuit, current ज्यादा होता है, voltage will be very less. So the SCR have to carry current, average current for a longer duration compared to asymmetric configuration over here. Okay, rest everything is same. Okay, what about the expression V out average and V out RMS? Same, no change at all because the wave shape is remaining the same. Here it is. Whatever you have written, the same will be valid. Okay. अभी एक बात बताओ, सुनो. Everyone, what is input V in? What it is doing? It is generating a 0 to 230 and 230 to 0, 0 to minus 230 and minus 230 to 0 sinusoidal wave which is periodic. Pure sinusoidal hai. This is correct. It's a pure sinusoidal periodic waveform. Correct. Now you are applying it to converter. This is a semi-converter. And what does the semi-converter do to that input current? Is it close enough to sinusoidal now? No. It contains harmonics. कैसे? ये देखो. Previous case. It contains ripples also. These are ripples. And pure square wave. यहाँ पे आ रहा है. It is working like a pure square wave. So this is not at all close. And what is the displacement angle? What is the angle between them? See, P in is starting from 0, but IN is not starting from 0, it is starting after alpha. So there is a phase difference between V in and IN. Who has created that phase difference? The converter. Because we are delaying the start. हम लोग को क्या करना है? T1 we are delaying by alpha. Right? That delaying is causing a phase difference between IN and V. Are you following? So there is a problem with this. There is something called as load current. अभी देखो, this red color one is my V. This blue color one is what I get, which is I in without ripple. But my fundamental current should be like this, sinusoidal, right? What's the difference? So there is a phase difference between my ये harmonics है. ये ऐसा square wave मतलब it contains harmonics. You understand harmonics, right? Sinusoidal waveform you can represent in terms of Fourier series. So higher order terms क्या है? Harmonics है. Correct? So it contains harmonics. So ये जो phase difference है between the line voltage and the fundamental line current is called as alpha. And this alpha is called as displacement angle. So phi V voltage. Phi 1V voltage. You might have missed probably one lecture was there in between explaining parameter, performance parameters of converters. So I uploaded the recorded video. You watch that. Or else you won't understand what is that. What are the different parameters? We are going to repeat that on Friday. Next lecture, we are going to repeat that for semi-converter. So if you have missed something, you can refer semi-converter also. But only the main formula V out average will be different for both. The rest everything is same. Almost similar. Right? So cos of that alpha is my displacement factor. मतलब when we apply a sinusoidal, pure sinusoidal waveform at the input is pure sinusoidal, but input current is distorted. It's becoming a harmonics. अभी ये जो harmonics है ये input current है. Actually, do you know wires are actually also RL? Wires also is have impedance. It's a transmission line. You have heard of it? A piece of wire is also a transmission line. It has RL. Piece of wire can be RL load. So current will flow to RL load or distort over. So it will contain harmonics. What I am saying is this. Practically, ये जो wire हम लोग ने ऐसे connect किया ना, practically it doesn't that way. This also contains ऐसे RL. So when harmonic current will flow through this R and L, it will again distort it. Again, it contains more harmonic. And तुमने डिजाइन किया है इंडक्शन मोटर, लेट्स से यू हैव डिजाइन अ इंडक्शन मोटर और लेट्स से एसी मोटर, to work only on pure sinusoidal और तुम लोग हार्मोनिक दे रहे हो, it should work with pure sinusoid, right? Let's say पॉजिटिव हाफ साइकिल में एक डायरेक्शन में घूमी, नेगेटिव हाफ साइकिल में कंटिन्यूस घूमी, बट because of this harmonics it will not function properly. So actually converters introduce harmonics in the system, but the solution it create कर रहे problem. When we are trying to convert AC to DC, we are indirectly introducing harmonics also. इसको निकालोगे कैसे? Again the circuit will only help to harmonics. The AC सब में this will be discussed. Are you understanding the meaning of this? So draw this somewhere. This is important. Load current contains harmonics. It's almost like a square wave. What do you mean by displacement factor? Displacement factor is cos alpha. And what is alpha? We know. It is firing angle. Does alpha and phi are same? Yes. Because we are delaying now. So alpha can be less or more? Yes. So yet this also will be shifting like left and right. Because we decide now what should be alpha. So there is a phase difference and there are harmonics. The fundamental current will be sinusoid. But this blue color one which we are getting out of the converter is containing harmonic. That's why it is a square. You have never done harmonics का study before anywhere? Mathematics में? While we discuss performance parameters of semi-converter, we are again going to see that one quickly. Okay? At least लिख तो लो displacement factor क्या होता है? Displacement factor is cos alpha. You have written? अच्छा, here I have written ion without ripple. अगर ripple होते तो कैसे दिखता ये? How would that look like? Correct? In the first case, a symmetric configuration, it was containing ripple. Completed? Quickly, please. This is explained well in P.S. Vimra book, and also it's given in Kanchandani. These two books cover relatively entire syllabus. Don't just rely on these handouts. Huh? You also start exploring lot more from there also. Okay. So what are the problems with the converter? Now, since you have missed that lecture of performance parameters, there is something called as reactive power. There are three types of power: active power, reactive power, and apparent power. You have heard of it? First year में सुना रहेगा in EEE. Power triangle. याद आ रहा है? So reactive power is not useful, but SCR converters have reactive power QI. So the circuit will demand QI. Therefore, because the displacement factor is not equal to unity, हम लोग alpha 0 कर सकते हैं? नहीं ना? Alpha is the firing angle. So alpha will be greater than 0 but less than 90. So alpha 0 नहीं है तो unity नहीं रहेगा. That means there will be a reactive power. Reactive power मतलब waste, जो use नहीं होगा जिसका. The currents are far from being perfect sinusoids because of large harmonic content present over here, as you have seen, right? So this will lead to harmonics in voltage also, and harmonics are problematic. So a pure sinusoidal expected at the input will be like a harmonic, I don't know what wave, and which will be not be good for the load, which is a motor. Motor is expecting sinusoidal, but you are giving harmonic voltage. It will not function properly. Yeah. So that will be it for 14 point A. Now let us start with 14 point B. Draw the wave, I mean the circuit, single phase semi converter with RLE load and freewheeling diode. Continuous load current case. Functioning is exactly the same. I'll tell you what is the differences. I'll only say the differences. Draw the circuit diagram, please. It's a symmetric configuration. We are assuming a continuous load current and we have a freewheeling diode. T1 and T2 are the SCRs and D1 and D2 are the power diodes. In case of continuous current, load current conduction, the working is almost same, because in case of continuous load current conduction, we don't care about the load. We just care about how the, when does the SCR turn on, and it will function as per the SCR turning on at alpha, at pi plus alpha. But only if there is a discontinuous mode, only then your load will come into picture. Okay? Continuous load current. Can I start? DFWD is what? Freewheeling diode. It's a freewheeling diode. Now, just now, in the previous section, I've explained what's the role of a freewheeling diode. Pi to pi plus alpha में वो on हो जाएगा, and it will freewheel the energy. Same thing will happen over here. Okay. Only one difference is there. That difference I'm telling now. This is the difference. Alpha should be greater than theta 1. कैसे ये देखो. Now, E is a constant value, right? So you should carefully select that firing angle should be greater, alpha should be greater than theta 1. If it is before, it will not function. It will function, but it will only function at theta 1 then. It will not be under your control then. So you should see to it that when you apply a firing angle, alpha, it should be greater than theta 1. Matlab, P should be greater than E. If V is greater than E, then only your T1 SCR will be forward bias. Only ये है बस, बाकी सब same है. Entire waveforms are same. देखो, exactly the same. Also, there is an additional freewheeling diode current which is coming up. Now, what is this freewheeling diode which is coming up? I'll explain that. Now, in this waveform, if the current flows, let's say this is I in current. Let's say that this diode is on. Let's consider this diode is on. So this current is IFWD and this is outgoing current. So ये node में तीन current आ रहे हैं. One is incoming, which is I in. Another one is incoming, which is IFW, and one is outgoing. So can you apply a KCL over here? Yes. So what will be the equation? I out will be equal to I in plus, yes. I out will be equal to I in plus freewheeling diode current. यही है ना? यही है. इधर भी यही है. देखो, ये I out है. This is I in. This is I in, and this is I out plus I in. अगर जोड़ दोगे, तो you will get back I out. I mean I out, I in plus I freewheeling diode. If you connect them together, you will get I out. See this. Oh, sorry. This I out will be equal to I in plus IFW. When it is when it is a negative half cycle, I in current will be negative, but freewheeling diode will be positive. Why? Because load current will always flow from C to D. If this is C, this is D, load current will be unidirectional. It will not change. Why it is unidirectional? because SCRs are unidirectional. It does not allow the current to flow in the reverse direction, like diode. So current will always be positive. अगर current always positive है, मतलब IFWD will always flow like this. So IFWD always will be positive. That's why it is positive over here. Okay. Now I'll explain the waveforms from here. Here it's only explain the working from here. ये समझ गया? What is the condition? P in should be greater than E. In short, alpha should be greater than theta 1. Then only it will function as previously which we have considered. Now, this firing angle at alpha, pi plus alpha, you'll remember. Shall I move down? Yeah. So now, what happens between alpha to pi? T1 and D1 will conduct. Any doubt in that? Here it is, right? Output will follow the input and ion will also follow the output. And the freewheeling that is not on yet. Now, from pi to pi plus alpha, what happens? Again, this trigger pulse should be greater than, beam should be greater than E. So this should be ahead. Pi plus alpha should be ahead than this line, dotted line. Only it will function properly, right? Now, again the inductor stored energy will start releasing the energy and the current will slightly fall, but not to zero, but to a minimum value, right? Now what will happen? Now we have said output voltage is zero and freewheeling diode is working. How freewheeling diode turns on? Freewheeling diode on कैसे हो गया? ये देखो इधर देखो. See here. Right now, what is this situation? This is situation as pi plus. Why I am saying pi plus? Because at pi, your input voltage is zero. Pi plus में V is reducing, right? It's going negative. At pi plus, what happens? T1 becomes off. Reverse bias आ गया ना इसके across. T2 is already off. Forward blocking में फिर भी off है. D1 is off. D2 is on. D2 reverse bias में on होता है ना, मतलब negative half cycle में. So what will happen? This positive will reach over here. बराबर? This negative will come over here. This negative. I mean, what is this reverse cycle ना? This is negative half cycle. So this polarity, what it will do is, it will make this this diode on. इधर पता चल रहा है क्या यहाँ पे? हाँ, यहाँ पे देखो. ये positive है ना? This positive is applied to anode. तो forward bias हो गया ना? यही हो रहा है ना? This is becoming forward bias because of this positive coming over here. So that's why freewheeling diode will turn on. And when the freewheeling diode is on, entire energy stored across the inductor will be flowing through this loop, and output voltage will be zero, and ion will be zero. But यहाँ पे अगर freewheeling diode से current flow हो रहा है, तो current तो थोड़ा रहेगा ना freewheeling diode का. So that current is this current. So from pi to pi plus alpha, your freewheeling diode will be on, and some freewheeling current will flow. Rest everything is same. Now from pi plus alpha to 2 pi, again T2 will conduct and D2 will conduct, and again the output will follow negative of input, right? And again from 2 pi to 2 pi plus alpha, again the freewheeling diode will be on, and the story will repeat itself. समझ में आया? What happens? What's the difference over here? Whenever the freewheeling diode is on, some current also flows through that. Because of that, that current equation which you have written, what is that equation? I out is IN plus IF W. Okay? Do you have any questions? Huh? E लगाने का फायदा is coming in discontinuous mode. E लगाने का फायदा क्या हुआ? I'll tell you. Whenever you connect the E over here, let's say current starts flowing. Now battery को charge कैसे करते हो? When you have a mobile adapter, you turn on and current starts flowing, तो battery charge होता है. यहाँ पे मुझे battery charge करना है, let's say. ठीक है? I have a, let's say electric car है. मुझे उसका battery charge करना है. So I'll connect the battery in this loop. So whenever the moment the current flows through that battery, it will start charging. समझ में आया? So that's the use of RLE load. or E also stands for RLU. Not, it's not always a battery connected. It might be a back EMF of a DC motor. Are you following? That's the use of RLE load. Yes or no? देखो इधर और एक चीज से बता रहा हूं देखो. What is V out? करंट कैसे होता है इसका? I out into R, बराबर है. इंडक्टर के अक्रॉस करंट इज कांस्टेंट, तो वोल्टेज कितना होगा उसका? जीरो. कैसे? देखो VL रहता है L di/dt. अगर मेरा करंट कांस्टेंट है तो कांस्टेंट ऑफ अ डेरिवेटिव इज जीरो, मतलब VL जीरो हो गया. तो व्हाट विल कम हियर? This will charge the battery. Current flowing through resistor is lost. Current flowing to inductor, it will store the energy. And current flowing through the battery will charge the battery. ये उसका मीनिंग है. बोलते हैं ना हम लोग 2 एम्पियर्स अडाप्टर, 3 एम्पियर्स अडाप्टर, फास्ट चार्जिंग, वही तो होता है. या चार्जिंग द बैटरी ऑफ योर मोबाइल. दैट्स द मीनिंग ऑफ RLE load. I am giving you an assignment for next lecture till Friday. So this is now a summary of conduction and the freewheeling period. See, I am not discussing much in details because the entire operation is similar. You should only know that during freewheeling period some current will flow, right? And the derivation is also same. Write down the circuit turn-off time. It's also same. ये भी same है. Pi minus alpha upon omega. ये क्यों बोल रहा हूँ? In the numericals it might come. Calculate the circuit turn-off time TC. This is also same. This is what you have to do. In case this is your assignment, work for the next lecture. The same circuit for discontinuous load current, plot the waveforms of V in, IG, I out, V out, and I in and freewheeling diode current. You try to draw the waveforms on your own for this circuit for discontinuous mode. Discontinuous mode, what is the meaning of it? I out goes to 0. At what? At omega t equal to beta, right? Pi plus beta, 2 pi plus beta, and so on. So I am showing you the waveforms. This you have to. This is how it will look like. If तुम्हें कुछ आएगा तो then you have really understood this thing. So this you have to do it next time and come. Okay. So next time I'll start with the performance parameters of semi-converter. So that will be the last lecture. After that we'll start with 3-phase full converter and semi-converter with R load. With that your ISC topic will be over for module number 2.